friends. This is a video on geometric sequences, and I'm going to show you how to write a rule for a geometric sequence and how to use that rule to find a further value or further number. So the first thing that we need to identify is our sequence geometric? In other words, is it being multiplied by the same value over and over again? So multiplied by same value. And we call that value that we're multiplying by repeatedly the common ratio. So it's similar to an arithmetic sequence where we would be adding the same number every time, but here we're multiplying the same number every time. So I'm going to ask myself, well, how do I get from -3 to -12? And I'm thinking in terms of multiplication because I'm trying to figure out if it's geometric. So, well, I guess if I were multiplying, I would multiply that by 4. And then is it the same pattern to get from -12 to -48 that I would multiply by 4? And is it the same pattern again to get here? And it is. So the common ratio, which we call R, and I'll take a minute to write that out. So our common ratio, which we refer to as R, in this case is 4. We're multiplying by 4 every time. So we're going to find a function. We're going to write a function rule for an input value n now that has a common ratio of 4. And just like with the arithmetic sequence, we want to know, well, what value do we start with? So what's our starting value in this ratio or in this sequence? And then we're going to multiply that by whatever that common ratio is. But because repeated multiplication is the same as raising something to a power or an exponent, we're going to then raise that ratio to the number in the sequence -1 just to adjust for the shift, right? Because we're not starting at the 0th term, we're starting at the first term. So this is going to be our general rule for a geometric ratio. So in other words, for this case, I'm going to write the function of n when my starting value is -3, so I've got -3, times my common ratio, which is 4, to the n minus 1 power. And that's my rule. So now if I wanted to solve that for 8th term, for example, I could plug in f of 8 and say, well, I'm going to multiply -3 times 4 to the 8 minus first power. When I simplify, I'm going to start with the exponent and start with the parentheses there. So I'm going to do -3 times 4 to the 7th power. And I'm going to get my calculator out here, literally getting it out. And I'm going to do 4 to the 7th power, which is 16,384. And then, so 16, I'll just put this here, so -3 times 16,384. And then I'm going to multiply that by -3, giving me -49,152. Let's take a look at a second example. This example, you'll notice, is going down, right? The values, well, actually, the values are going up from -2 to -1. That's getting bigger. And from -1 to -0.5. But I think when we're multiplying here, we're multiplying by half, right? -1 is half of -2. -1/2 is half of -1. So I could think of that as 0.5 or 1/2, right? Think of it either way there. So my R value here, my common ratio, is 1/2. So I'm going to write the rule in the same way. I'm just going to start with my first term. So my function here starts with my first value, which is -2. And now my R value is 1/2. raised to the n minus 1 power. So here, if I wanted to find f of 8, I would just plug in 8. So to the 1/2, 8 minus 1, which is f of 8 is equal to negative 2 times 1/2 to the 7th power. And if I raise 2 to the 7th power, I get 1/28. So I've got negative 2 times 1/128. And I can just do a little cross canceling there. And so that's going to be negative 1/64, okay, which I could leave in fractional term, or some of you might prefer to do decimals. And so for those of you that prefer to do decimals, it would be, I would need more room, so I'll just, or equals negative 0.015625. I kind of prefer the fraction there. It seems a little simpler. Okay, but that's how you're going to use the geometric sequence. So just remember that the geometric sequence is the repeated multiplication from term to term, right? So, and you can multiply by either a whole number or an integer, or you can multiply by a fractional term, okay? I hope that helps. Thank you so much.